Guys, welcome to my YouTube channel. So this is physics or science paper 1 representation. So I have multiple choice questions. So the first question reads, a simple pendulum swings between points P and Q as shown. It takes 0.65 seconds to swing from P to Q. So it is taking this simple pendulum to swing from point P up to Q, 0.65 seconds. Then the question is saying, a student measures 5 complete oscillations. So we can correct the data here. So we have the number of oscillations which are 5. Okay. What time does he record? What time does he record? So they are asking us to calculate what? Time. So time here we don't have. Now, let's find the period of the pendulum. So by definition, when you talk of the period of the pendulum, it is just the number of oscillations made in 1 second. The number of oscillations made in 1 second. Now let's try to look at the number of times, or the time that we are going to obtain when the bulb moves from P up to Q and back to what? Same position, which is P. Mind you, when this student was recording the time, he just recorded the time when the bulb moved from P up to Q, which was 0.65 seconds. Now, this one wasn't the complete oscillation. So we need to obtain the time for one complete oscillation. So we can just say, when the bulb moves from P up to Q, it is going to take how many seconds? It is 0.65 seconds. Now what about when it moves from Q and back to P? So we can just say, for us to obtain the time, we are going to say 2 multiplied by 0.65. Then the time or the period of the pendulum, so we can say the period of the pendulum is just going to be 1.3 seconds. This 1.3 seconds, it is coming from when the bulb moves from P up to Q and back to the same initial point, which is P. That is one complete oscillation. Meaning, the period of the pendulum that we have here, it is just 1.3 seconds. Now let's calculate time. So, by using the formula, we can just say the period of the pendulum is equal to the time taken over the number of oscillations. So we are calculating time here, so we can make T the subject of the formula. So we can say T is going to be equal to the period of the pendulum multiplied by the number of oscillations. So we have the period of the pendulum, which is 1.3 seconds, multiplied by the number of oscillation, which is 5. Then when I multiply, I'm going to get 6.5 seconds. So in this case here, 6.5 seconds is same as 6.50 seconds. So we can just say our final answer is just going to be C. The next one. The diagram shows the speed time graph for a moving object. So we have the speed on this side and time on this side. So the question is saying, what is the distance traveled by the object in 4 seconds? So 4 seconds, it is ending here. That is where we are having 4 seconds. So now, the area under the graph is equal to the distance traveled by an object. So we can identify the shapes that we have on this graph. So the first shape is going to be a rectangle. Then the next one is going to be a trapezium, which is this one. So we can just say distance is going to be equal to, so the formula for calculating the area of the rectangle, it is length multiplied by breadth. Then we need to add with the area for calculating the trapezium, which is 1/2, which is half. Then open bracket A plus B multiplied by the height. So let's continue. So we have the length from 0 up to 2, which is 2 itself. Then multiplied by the breadth. So the breadth, it is from 0 up to 10. So the breadth here, it is just 10. Then we can say plus half, then open bracket. So the value of A and the value of B comes from the lines which are parallel to each other. In this case, the lines which are parallel to each other are these lines. Okay, so these lines are parallel to each other. So it's up to you to choose which one is going to be the value of A and which one is going to be the value of B. You can take this one as the value of B, or you can take this one, the same one, as the value of A. It's up to you. So we can say the value of A, it is the distance from this point up to this point, which is 10. So we are going to say 10, then plus. The distance from this point up to this point, it is this one, which is 20. So we are going to say plus 20, then close. Then the height, it is from 2 up to 4. So to know the height here, we can just say 4 minus 2, because we are not starting from 0. So we need to say 4 minus 2, which is giving us 2 as our height. Then I'm going to say 2 multiplied by 10, we are going to get 20. Then plus, we can say the half of 2, it is just 1. So we have 1 here. Then 10 plus 20, we are going to get 30. So we need to say 30 multiplied by this one here. We are going to get 30. Okay. Then from there now we can conclude by adding these two numbers. 20 plus 30, we are going to get 50. So we need to say 50 meters as C as our answer. So let's move on to the next one. So the next one is saying a block of mass 4.0 kgs is put across a rough horizontal surface with a force of 30 newtons. With a force of 30 newtons. Right. Then the acceleration of the block is 2.5 meters per second squared. What is F, which is this one here? What is F? So F is just representing the frictional force. Okay? So it is just representing the frictional force. So when you talk of frictional force, it is just a force which opposes the motion. So F is opposing the motion. So what is F? The force of friction between the block and the surface. So let's try to calculate that one. So when forces are acting opposite to each other, we need to subtract. So we need to do something like this. Let's do this. Okay. When you have a force, suppose you have 20 newtons on this side here. Then you also have 50 newtons, which is acting on the opposite side of these 20 newtons. For you to know the resultant force of forces which are acting opposite to each other, you need to less the smaller force from the bigger force. So what I mean about this one, if you want to find the resultant force of these two forces which are acting opposite to each other, you need to get the bigger one, or the bigger force, minus the smaller force. So in this case, the smaller force is just 20 newtons. Always, you need to less smaller force from the bigger force. Okay, so to calculate the resultant force here, we can just say we are going to have 30 newtons, because 50 newtons minus 20 newtons, that is 30 newtons. So that one was just an example. Another one, if you have a block on the surface, then you have two forces which are acting on the same direction. Suppose we have this one as our 1 newton and this one as 5 newtons. For us to know the resultant force here, we need to say resultant force is going to be equal to, now since the forces are acting on the same direction, so we need to add. So we need to say 1 newton plus 5 newtons. Then the answer is just going to be 6 newtons. So that is how you are supposed to answer. That is how you are supposed to answer. When forces are acting on the same direction and when forces are acting on the opposite directions. Two ways of you answering force F here. First one, you need to consider the force of 30 newtons and the mass of 4 kgs. By calculating the acceleration. So force is given by mass multiplied by acceleration. So when you're finding acceleration, you need to make A the subject of the formula. So we can just say acceleration is going to be equal to force divided by mass. So let's calculate the acceleration here. So the force that we have, it is just 30 newtons divided by 4 kgs. Then the answer for acceleration is just going to be 7.5 meters per second squared. So this one is our acceleration. Now, this acceleration that we have found here, it is just showing us that when we ignore F, which is the friction force, this block is going to accelerate with the acceleration of 7.5 meters per second. Right? I'm saying if we ignore F, which is the frictional force, if we ignore it, this object is going to accelerate with the acceleration of 7.5 meters per second. Right? Now, in the same question, they have given us the acceleration of this block as 2.5 meters per second squared. Meaning, if we get this acceleration of the block and less it from the acceleration of the block when we ignore F, we are going to find the acceleration of the frictional force. Right? So let's do that. So we are going to say 7.5 meters per second squared minus 2.5 meters per second squared. Then when I do the computation, I'm going to find the answer as 5 meters per second squared. So this one is the acceleration of the frictional force. This one is the acceleration of the frictional force. Now let's try to find the original force of F by using the same mass, since mass does not change. So we're just going to use the same mass, which is 4 kgs. So we are going to say force, which is F, is going to be equal to mass multiplied by acceleration. So the mass does not change, so we need to just take 4 kgs multiplied by 5 meters per second squared. Then the answer, when we multiply here, it is just going to be 20 newtons. So this 20 newtons was the force of what? F. It was the force of what? F. Now I'm saying there are two ways of you answering this force F. So let's also see the next one. Okay, so the next one, it is by taking this acceleration of the same block and also the same mass. So we can say, when we take this mass here and also the acceleration of this block here, we are going to calculate the resultant force. So we can say the resultant force is going to be equal to mass, which is 4 kgs, multiplied by the acceleration, which is 2.4 meters per second squared. Then when I multiply here, I'm going to get 10 newtons. This 10 newtons, it is the resultant force, not the force of what? F. It is the resultant force. So for you to know the force, which is F, what you are going to do, you are going to take this one here and less the resultant force from 30 newtons. So we are going to say 30 newtons minus 10 newtons. Then the answer is going to be 20 newtons. So you need to choose which one is simple for you to answer this one. So we can just conclude that the answer here is just going to be B. Okay, so in conclusion, you can say, since these forces, they are acting opposite to each other. And then I was saying, when forces are acting opposite to each other, so we have already found the force of F, which is 20 newtons. So let's calculate the resultant force here. So we can say resultant force is going to be equal to, so we can say 30 newtons minus 20 newtons. Then the resultant force is just going to be 10 newtons. So that's the resultant force. Let's move on to the next one. This one is saying, a girl lifts an object of mass 1.0 kgs from the floor and puts it on a ledge 2.0 meters above the floor. How much potential energy is gained by the object. Take gravitational field strength at G is equal to 10 newtons per kgs. So the first thing here, you need to know the formula for calculating the potential energy. So potential energy is given by mass multiplied by the acceleration due to gravity multiplied by h, which is the height in this case. So the mass we have 1.0 kgs multiplied by the acceleration due to gravity, which is 10 newtons per kgs, multiplied by the height. So the height here, it is just 2 meters. So 2.0 meters. Then when I multiply, I'm going to get 20 joules. So usually potential energy is just measured in joules. So the answer is just going to be D. The next question. Measuring cylinder contains water. 5 identical metal screws are added to the water as shown. So when they use the term identical, identical means same. So which means these screws, they are the same. Since they are the same, which means they are going to have the same mass when they use identical. That is one thing that you need to know. Right. So the question continues by saying the mass of each screw is 3.8 grams. The mass of each screw is 3.8 grams. Then they are from saying these screws, they are identical to each other, which means they are the same, and they are going to have the same masses. And here they are saying each, which means one screw is going to have the mass of 0.8 grams. Now, how many screws do we have in this cylinder? So we have about 5 screws. So to know the total mass, we are going to say 5 multiplied by 3.8 grams. Then the mass of all these 5 screws is just going to be 19 grams. When you multiply 5 multiplied by 3.8 grams, you are going to get 19 grams. Right. So the question is just asking us to calculate the density of the metal of the screws. So what is remaining here is for us to identify the volume of these 5 screws. So initially, water was having the volume of, so we can say the volume, which is volume 1, is going to be equal to. So you need to be very, very careful on how they are counting the numbers. So we can say at this point here, this one is 6.2. So that is 6.2 centimeters cubic. So they are counting one line as 2. Okay, so when you move from 6, then the next one is going to be 0.2. Okay, so it is 6.2. Then let's come to after screws are added. So after screws are added, we are going to find that the volume rises up to this point here. Now this one here, as you can see very, very, very clearly here, we can just say this one is going to be 8.6 centimeters cubic. So I am from saying these small lines that you can see here, these small lines, each line is representing 0.2. So that's why I'm saying this one is going to be 8.6. So we have 3 lines from 8 up to where the water is ending. Right, so we have the initial volume of water and the total volume of water and the screws. So we need to say volume 2 minus volume 1. So volume 2, it is this one, which is the volume for the total volume of the screws and the water. So we are going to say the volume of the screws is going to be equal to 8.6 centimeters cubic minus 6.2 centimeters cubic. Then when I do the computation here, I'm going to find the answer as volume is going to be equal to 2.4 centimeters cubic. So 2.4 centimeters cubic is our volume of 5 screws. So let's calculate the density. So you can say this one is our mass. Then the volume here, it is just 2.4 centimeters. 4 centimeters. So density is given by mass over volume. In this case, the mass, it is 19 grams divided by the volume, which is 2.4 centimeters cubic. Then when I divide, I'm going to find the answer as 7.9 grams per centimeters cubic, meaning our answer is just going to be C. The next question. So the next question is saying the diagram represents a wave in air. Molecules are closer together in region P than they are in region Q. What are the names of the regions P and Q, and which type of wave is represented? So at this point, as you can see, the air molecules, at this point, the air molecules are complexed. Okay, so at P, we are going to have complexion. That's complexion. Then at region Q, that is rarefaction. So we have P as complexion, then Q as rarefaction. Now what kind of a wave is this one? So this one is called a longitudinal wave. It is called a longitudinal wave. So the answer is just going to be A. Now, when you talk of a transverse wave, the movement of a transverse wave moves like this. So you can say, for example, if we have an XY plane like this one, the movement of the transverse wave is going to move in this form or in this format, where we are going to have the maximum amplitude and the minimum amplitude. That's the movement of the transverse wave. The next question. The extension of a spline is measured for various loads. The limit of proportionality is not reached. So when they say the limit of proportionality is not reached, which means the spline is obeying Hooke's law. As the result, the curve is going to be straight, right? So if we have a graph like this one here we are going to have extension, then here we are going to have the load. So if the proportionality is not reached, the graph is going to be just straight without bending. So this one is not drawn to scale. Yes, so the graph should be straight when the spline is obeying Hooke's law. Next, so which graph shows the extension load graph for the spline? Since the proportionality is not reached, meaning the answer is just going to be B, right? When the proportionality is not reached, which means the spline haven't reached its elastic limit. The next question. The sound from a ship is reflected by a cliff. An echo is heard by a sailor on the ship 4.0 seconds after the sound is made. The speed of sound in air, it is 320 meters per second. How far from the cliff is the ship? So to make you understand this question properly, suppose we have a ship like this one. Okay, this one is not drawn to scale, so I'm just guessing if this one is the ship, and we have a cliff somewhere here. If this ship sends the sound up to this cliff here, we don't know the distance covered by the sound from the ship. So this one is going to be the ship. Then this one is going to be the cliff. Now, for the sound to reach the cliff, which means it's traveled from the ship up to the cliff. Now, this question is saying, how far from the cliff is the ship? So they are saying, how far? So we need to start from the cliff up to the ship. That's the distance that they are asking us. Now, when you define distance, we can just say distance, it is how far an object has traveled. It is how far an object has traveled. So in this case here, for the sound to reach the ship again, it needs to travel So the sound needs to travel from the same ship up to the cliff, then from the cliff up to the ship, because it is the same ship which has reflected the sound. Meaning, for us to know the distance from the cliff up to the ship, we need also to consider the distance of the sound traveling from the ship up to the cliff. Then also from the cliff up to the ship. Now, suppose if the distance from the ship up to the cliff, it is 4 meters. Then the distance from the cliff up to the ship also it is going to be what? 4 meters. By considering the distance here, we can just say the distance is going to be what? 8 meters. Distance is different from displacement. Meaning, if we talk of displacement here, the displacement is going to be 0. Right? So what we are going to do here, we are going to label this one as our distance 1 and this one as our distance 2. So which means here we have 2 distances. Now, by using the formula, which is velocity or speed is going to be equal to distance divided by time. Since here we have 2 distances, meaning here on D, we are going to say 2D divided by time. This 2D is coming from distance 1 and distance 2. Right. So let's calculate how far the ship is from the cliff. So we have speed being given by 2 distance divided by time. So in this case here, we can make 2D the subject of the formula. When I multiply here, I'm going to have 2D being equal to V multiplied by T. So 2D is going to be equal to the speed of sound in the air. It is 320 meters per second multiplied by the time, which is 4 seconds. Then when I multiply, I'm going to get 1,280 meters. So remember here we have 2D, meaning I'm going to divide by 2, even here by 2. Then 2 and 2, they are going to cancel each other. Therefore, D is going to be equal to 2 into 1,280. We are going to get 640 meters, meaning our answer is going to be B. Right, so the next one is saying, and X of a metal rod attracts the North Pole of a compass needle. Which statement about the rod is correct? So suppose we have the compass, which is this one. Then we have also the metal rod, which is attracting the North Pole of the compass. Okay, so we have A, which is saying it is made of copper that is not initially magnetized. So copper is not a good material for a magnet. So copper is not a good material for a magnet. So you can't make a magnet using copper. Meaning, even B is not going to be the answer because they have involved copper. Copper is not a good material for making what? A magnet. Or copper is not a material for a magnet. Meaning, it is not a magnetic material. It can't be attracted to a magnet. Then C, it is made of steel that is not initially magnetized. Okay, so let's keep this one here. Steel is a good material for a magnet. It can be attracted to a magnet. Then D, we have, it is made of steel with a North Pole. Now, if this metal rod is made of North Pole here, what is going to happen? There will be repulsion here. But in the question they were saying, and X of a metal rod attracts the North Pole. Meaning, this and X, which is this one here, let's suppose we say this one is our end X. Meaning, it is going to be attracted to this North Pole here. Like repose, they repel. Meaning, they are not going to attract. Then, unlike repose, North Pole and the South Pole, they are going to attract. So we can just conclude that the answer is going to be C, because This one was made of steel and it was not initially magnetized. When something has been magnetized, which means it is going to have the poles, which is the North Pole and the South Pole. So this one is just neutral. It is not having the North Pole and the South Pole. So the answer here, we can just say it is just C. Alright, so the next one is saying the diagram shows a ray of light passing into a semicircular block of plastic. Okay, so we have the plastic and the ray. This one is very, very important. Okay, so we need to consider where the ray is coming from and where the ray is going. Okay, so where the ray is coming from, we can say it is this one here. So this one is going to be our incident ray. So incident ray. Then where the ray is going, we need to say this one is going to be the diffracted ray. Okay, so this one is coming from reflection, not reflection, but reflection. Okay, so the question is saying, what is the refractive index of the plastic? What is the refractive index of the plastic? So refractive index is denoted by small letter n, given by sine angle of incidence, which is I, divided by sine angle of reflection. Okay, so it is very, very important for you to know the reflection here and also the angle of incidence. So the angle of incidence is formed between the normal and the incident ray. Okay, so I've forgotten to tell you that this one here, this line here, it is the normal ray or the normal line. Meaning the angle of incidence is going to be created between the same line, which is the normal, and the incident ray. So we can just say the angle of incidence is going to be 40. Similarly, the angle of reflection is going to be created between the refracted ray and also the normal ray or normal line. So which is this one, 25 degrees. So we can calculate the refractive index. So we have sine angle of incidence, which is 40 degrees, divided by sine angle of reflection, which is 25 degrees. Then when I punch on the calculator sine 40, it is going to give me 0.643 when I round off. So we can say the refractive index is going to be equal to 0.643 divided by then sine 25. Sine 25 is going to give me 0.423. Okay, so it is going to give me 0.423. Then when I divide 0.643 divided by 0.423, I'm going to get the refractive index as 1.5. Meaning the refractive index or the answer for this question is going to be A, which is this one. The next question. Okay, so the next question is saying radio waves, visible light, and X-rays are all components of electromagnetic spectrum. What is the order of increase? What is the order of the increasing wavelength? So, to know the increasing wavelength, we need to use a mnemonic key, which is my Rost mains. So we can say my Rost mains is very unusual Xmas gift. Okay, so we have my Rost mains is very unusual Xmas gift. So this my here, it has no use. It has no use. It is just included here to make a mnemonic key sounding properly or good. So we need to start with Rost. So Rost means radio wave. So we need to say R, which is the radio wave. Then the next one is going to be mains, which is M. It is going to denote the microwaves. And then the next one is going to be is, which is I, is going to be infrared rays. And then valley is going to be visible light. then followed by unusual, which is U, it is going to represent ultraviolet. Then Xmas, which is X, is going to represent X-rays. Then the last one, gift, G, it is going to represent gamma rays, which is also known as Y rays. Now, in this order, so let me just write gamma here. In this order, starting from the radio wave up to the gamma rays, this one, it is the order in the increasing of their frequency. That is the increase in their frequency. When you are coming from radio wave going to the gamma rays, the frequency increases. The frequency increases. Then when you talk of the wavelength, it is just the opposite. It is just the opposite of the increase of the frequency. Meaning, frequency is going to increase, starting from the gamma rays going to the radio wave. So this one is the wavelength, the increase in the wavelength. To conclude, we can just say radio waves, they have higher wavelength and lower frequency. And then gamma rays, they have higher frequency and lower wavelength. Now, let's see the multiple choices here. So here they are saying shortest wavelength. Shortest wavelength. So if we consider the visible light here, which is this one here, this one is going to have shortest wavelength. Then the next one, radio waves. No, radio waves can't have low wavelength. Okay, so the next one we have the radio waves. So the radio waves followed by the X-ray. Now X-ray, they have lower wavelength. Now here they are saying we need to have the longest wavelength. So question A. So option A is not the answer. Option B, we have the visible light, which is correct. It has the shortest wavelength. Followed by the X-ray. Yes, they have the shortest wavelength. Now, they are saying in order. This one here, it has the lowest, which means this one should start what? First. Followed by which one? The visible light. Followed by which one? The visible light. Meaning, even this one is going to be the answer. Let's see option C. Option C is having the X-rays. Yes, X-rays. This one here, they have the shortest wavelength. Then the next one, radio wave. No, radio wave, see, they have the highest or the longest wavelength. Meaning, this one is not going to be the option. D, we have the X-rays, which is correct, followed by the visible light. So the first D, we have X-rays, which is correct, followed by visible light, which is correct. Then the last one, which is the longest wavelength, which is the radio waves. So the correct answer here is just going to be D. So you need to be very, very careful when answering such kind of questions. Let's move on to the next one. So the next one is saying a mobile phone, which is the cell phone, takes 4.0 hours to fully charge from a 5.0 volts power supply. The charging current is 0.25 amps. How much electrical energy is transferred from the power supply? How much electrical energy is transferred from the power supply? So the first thing here, we need to know the formula. So electrical energy is given by E being equal to power multiplied by time. So the time here should be in seconds. Then power should be in watts. Right? Or if you want, you can say time should be in hours. Then power should be in kilowatts, whichever way you choose. But I'm going to choose for seconds, and watts. Okay, so let's correct our data. So we have voltage, which is 5 volts. Then we also have time, which is 4 hours. So 4 hours, for us to convert these 4 hours into seconds, we need to multiply it by 3,600 seconds. Okay. Then the answer is going to be 14,400 seconds. Then the last one we have current. So current is going to be equal to 0.25 amps. That's our current. So in the place of power, we can say power. Power, the formula for power, it is power is equal to voltage multiplied by current. So in the place of power, we can just say voltage multiplied by current. So voltage multiplied by current multiplied by time, which is this one. Right, so voltage we have 5 volts. Then current we have 0.25 amps. Then the time, it is this one here. Okay, so we need to put it here. So when I do the computation, the answer is just going to be 18,000 joules. So electric power is measured in joules. So our final answer is just going to be D, which is 18,000 joules. The next one. 3 metal bars are shown in the diagram. So we have W, X, Y, and Z. It is found that the end W attracts both end X and Y. Now, if this W is attracting both ends X and Y, which means this one is a metal, because a metal which is neutral, it can be attracted to both sides. Whichever pole you brought near to it. So they are saying it is found that the end W attracts both end X and end Y, but repels end Z. So this W is repelling Z. Now, let's just take into consideration, if we say W is going to be the North Pole, even Z is going to be what? The North Pole, because like repels, they repel. Like repels, they repel. Meaning, if we bring W close to Z, they are going to repel each other. Now, if we bring this North Pole to the end X, it is going to be attracted. And also, if we bring the North Pole to the end Y, it is going to be attracted. So let's see the question. Which of the bars are permanent magnets? This one is not a permanent magnet. It is just a metal. For this side here to be attracted to the both sides, which is X and Y, which means this one is just a metal. The permanent magnets are just 1 and 3, because they are repelling to each other. If we bring this side close to this side here, they are going to repel, which means these are permanent magnets. So the answer here is just going to be C. This one is very, very important. You can try to reverse back the video so that you understand what I'm talking about here. The next one. Which list consists of 3 regions of the electromagnetic spectrum in order of increasing wavelength, which is lowest first? So we need to start with the lowest first. So my lowest means is very unusual Xmas gift. That's the mnemonic that we are going to use. So we have R representing the radio waves, M representing the microwaves, then is, which is I, it is representing the infrared, then V, which is representing the visible light, followed by U, which is unusual, it is representing the ultraviolet. Then we also have X, which is X-ray, which is X mass gift, which is X mass. Then the last one, which is gift, which is G, it is representing the gamma rays or Y rays. So I was saying, starting from the radio wave up to the gamma rays, this one shows the increase in frequency. So this one shows the increase in frequency. Then starting from gamma up to the radio waves, this one shows the increase in wavelength. Meaning, gamma rays, they have lowest wavelength and highest frequency. Right. So they are saying we need to start with the lowest first. So the lowest first is going to be the radio waves. Okay, so we need to have radio waves followed by, if we pick the radio waves, they are going to have the lowest frequency. Then the next one is going to be the microwave, which is this one also. They are going to have the lowest wave, the lowest frequency, but more than the radio waves. Then followed by the ultraviolet waves, which is this one here. Meaning, this one is showing the increase in their frequency. We can conclude that the answer here is just going to be C. The next one. There is a current of 12 amps in an electric kettle. How much charge passes through the kettle in 1 minute? So the time here, we have 1 minute, which is equivalent to 60 seconds. 1 minute is equivalent to 60 seconds. Then apart from that one, you also have the current, which is denoted by I, being equal to 12 amps. Then they are asking us to calculate the charge passes through the kettle in 1 minute. So we don't have the charge here. So current is given by charge over time. If we make charge the subject of the formula, we are going to get Q, which is the charge, being equal to current multiplied by the time. So the current, it is just 12 amps multiplied by the time, which is 60 seconds. Then when I multiply, I'm going to get 720 coulombs. So coulombs, we usually use capital letter C, which denotes coulombs. So the coulombs, they are just SI units for charge. So the answer is just going to be D. In one radioactive decay, radium-226 decays to radon-222 as shown. So the mass number here has been reduced by 4, and the atomic number has been reduced by 2. Meaning, if we have element Y, which is having, suppose we have element Y, which is having 23 as the mass, then the proton number of 11, if this one undergoes a certain decay, what is going to be formed is going to be X now. Since they are saying here the mass has been reduced by 4, meaning this one is going to be 19, right? So this one is going to be 19, and the proton number has been reduced by 2, as you can see, from 88 up to 86, meaning this one is going to have 9 or so. Meaning this one is going to have 9. Now, they are saying which particles are also produced. Which particles are also produced. Alright, so this decay, which is being shown for the radium to decay into radon, which is 222. This decay is called the alpha decay. So, meaning this one, it is just showing an alpha particle. Only it is an alpha particle. So the answer is just going to be B. If it was the beta particle only, meaning the mass number is going to remain the same, which means the mass number is just going to be 226, and the proton number is going to be added by 1. So from 88, it is going to be 89 if radium undergo beta decay. So let's move on to the next one. So the next one is saying the diagram shows the emissions from a radioactive source passing between two charged plates. One plate is positively charged and one is negatively charged. So we have the positively charged and the negatively charged. What types of radiation reach the detector? So the detector is here. So as you can see, we have the radiation being deflected to the positive charge, and also the emission, the radioactive emission being deflected to the negative charge. So let's identify the alpha particle. Alpha particles, they are positively charged in nature. And what you know is that when you have positive, here there will be repulsion. Then when you have negative and negative, there will be repulsion. But when you have negative and positive, there will be attraction here. Meaning, alpha particle is positively charged in nature, meaning it is going to be deflected to the negative charge. If you say it is going to be deflected to the positive charges, meaning there will be repulsion. And beta particle, it is negatively charged in nature, meaning it is going to be deflected to the positively charged plate. Now, the detector or the radiation which is going to reach the detector is going to be the gamma radiation or Y rays, because gamma radiation, they are neutral in nature. They are neutral in nature. So the answer, it is just going to be gamma rays only, which is D. Let's move on to the next one. So the next one is saying a radioactive material gives a count rate of 80. A radioactive material gives a count rate of 80,000 counts per minute. After 20 days, it gives a count rate of 500 counts per minute. What is the half-life of the material? What is the half-life of the material? So let me give you the formula to use. Number of half-lives is equal to the time taken divided by the half-life. So small letter t is representing the half-life. Then n is representing the number of half-lives. Then capital T is representing the time taken. So you need to be very, very careful when using this formula. Right. Okay, so we have the original mass. We have the original mass of 8,000. So what we are going to do here, when you talk of half-life, suppose you have something like 4. What is the half of 4? So the half of 4 you need to multiply it by half, which is 1 over 2. So the half of 4 is going to be what? 2. What I'm trying to elaborate here is when you have 8,000. So the last count was 500 counts per minute. Meaning, we need to reach at what? 500. So let's do this. If we say, what is the half of 8,000? The half of 8,000 is going to be 4,000. Then the half of 4,000, it is going to be 2,000. Then the half of 2,000, it is going to be 1,000. Then the half of 1,000, it is going to be 500. That is our ending. Now, these lines, this one, this one, this one, and this one here, they are representing the number of half-lives for this material to decay from 80,000 up to 500. Right. So now, since these, they are representing the number of half-lives, so let's count the number of half-lives that we have here. So we have 1, 2, 3, 4. So we have 4 number of half-lives. Right? So we can say we have 4 number of half-lives being equal to the time taken. What is the time taken? After 20 days. So 20 days is the time taken. So we can say 20 days divided by the half-life, which we don't know. So when I multiply here, I'm going to get 40 being equal to 20 days. Then when I divide by 4, even here by 4, this t is going to remain alone, which is the half-life. So 4 into 20 days, we are going to get 5 days. So the answer here is just going to be B, which is 5 days. Now